Welcome to the lecture on decisions under risk and uncertainty. In this lecture, we will be studying the case in which the expected value decision making is used. Now, expected values are basically helpful in making decisions under uncertainty, and basically it uses the concept of probability. We have already discussed that the probability of associated events are taken into account. The product of probability of a variable will be taken with its numerical outcomes, and it will be summed over all possible outcomes. So, this way you get the expected value, and these are basically used for long run conditions when the event is assumed to occur repeatedly, and sometimes also in the cases when you have initial investment and its effect is basically visualized in the future. So, in those cases also this concept is used. Now, let us take a case which has been about the flood damage in a certain area where there has been history that there is probability that flood may come, and if the flood comes then it will do the damage to the crops. So, there is basically a proposal that a dam should be built now, or a levee should be built before the dam is made, maybe later on. So, before that basically you are trying to use this analysis in which there is history that how many years the level of the flood water is how much. So, basically the level of water is given as 5, 0 to 20, 40, 60, 80 and 100 centimeter. Suppose above the normal it goes. The history tells there has been occasions of 15 times during the last 50 years the level was 0. So, in that case there was no flood loss. Now, 12 times there has been the level of water 20 centimeter above normal, then you have 10 times, 8 times, 3 times and 2 times the level of water has been as 40, 60, 80 and 100 centimeter above the 0 level, and basically this level of water causes the damage. So, years, number of years the water level was above normal. So, this was the normal. So, if it is A, so above A. Now, the third is that what will be the loss? Loss is predicted if water level is above A. So, if the water level is above A, the loss is given as, because there is no increase in the level, there is 0 level, so loss is 0. Then in this case you have 6 lakhs, 9 lakhs and further you have 12 lakhs, 15 lakhs and 20 lakhs. This is the loss caused by the river if the water level goes to 20 centimeter above the normal, it causes a loss of 6 lakhs. Now, further you can cost of initial investment of making levee. So, of a centimeter. So, this cost is 0. This cost, if you make a 20 centimeter length of levee, it will be costing maybe 20 lakhs. This is 30 lakhs, this is 50 lakhs, this is 65 lakhs, and suppose this is 80 lakhs. Now, basically, depending upon this data, you have to find the probability of occurrence of the flood or the level of water in terms of the chance, and if you look at that, the chance you can compute as here itself. So, it will be 15 by 50 into 100. So, probability will be 0.3. This will be 0.24, this will be 0.2, this will be 1.6. No. So, this is out of 50. So, you have basically to divide it by 50, 15 by 50. So, it will be 0.3, 12 by 50. So, it will be 0.24, this will be 0.2, so it will be 0.16, this will be 0.06, and this will be 0.04. Okay. So, this is the probability that the level of water will be coming to 0, that is chance is 0.3, 20 as 0.24, 40 as 0.2, 60 as 0.16, 80 as 0.06, and so lesser probability is there that river water level will exceed to this level. Now, it is also seen that your study has to be done for 15 years, after which it is assumed that the government will basically make a permanent arrangement by making the dam. So, you have to study for 15 years. You have also interest rate as 12%. So, using this interest rate, you have to suggest what should be the height of levee to be built. Now, this is a case of expected value decision making. We can also use other methods, but we will see how we use this expected value decision making, by which you can suggest that what should be the height of the levee which should be made. Also, you have to see that as you go on making larger levee heights, the initial investment is going to be higher and higher. So, you have to justify what should be the basically actual height which gives you minimum of the cost. Now, let us say you are investing presently this amount. So, we will talk about the annual expenditure. So, if you take suppose 0 levee height, in that case you will have no present cost investment. So, your investment cost is 0. But you are losing all this, you are losing 6 lakhs when there is level of 20 and it is having probability of 0.24. So, if you look at that, the cost incurred because of flood, it will be basically 0.24 times 6 plus 0.20 multiplied by 9 plus 0.16 by 12 plus 0.06 multiplied by 15 plus 0.04 multiplied by 20. So, it will be basically, if the river level reaches 20 centimeter and its chance is 0.24, so that will give you a loss of 6 plus 0.2 times 9 plus 0.16 times 12 plus 0.06 multiplied by 15 plus 0.04 multiplied by 20. So, this is when you have 0 levee height, and you can get it by 1.44 plus 1.8 plus 1.92 plus 0.9 plus 0.8. So, this will come out to be 6.86. Now, let us say you are going to make a 20 centimeter levee. A 20 centimeter levee, for that you are giving initial construction cost of 20 lakhs, and basically this is to be used for 15 years. So, you have to find investment cost on annual basis, and so for that this 20 lakhs will be multiplied with, for it is for 15 years period. So, you have to multiply it with A by P I n, I is 12 and n is 15. So, you can see A by P I n 15, this is 12% for 15 years, A by P I n is 0.147. So, it is 0.147. So, it will be 2.94 lakhs. Now, let us say if the 20 centimeter levee is created, then what will be the loss because of the flood? Now, there will be no loss if there is 20 centimeter of water level, but if there is 40 centimeter of water level, in that case loss will be corresponding to 20 centimeter of height, and the probability of coming of 40 centimeter height water level is 0.2. So, 0.2 multiplied by loss corresponding to 20 centimeter height. So, that is 6 lakhs. Because this is levee is 20 centimeter height. So, once the flood level will be 40 centimeter, then the loss will be corresponding to 20 centimeters, that is 6 lakh, and the probability of having 40 centimeter height is 0.2. So, 0.2 multiplied by 6, similarly 0.16 multiplied by 9 plus 0.06 multiplied by 12 plus 0.04 multiplied by 15. So, this will be 1.2 plus 1.44 plus 0.72 plus 0.6. So, this will be $3.96. So, if you look at, you will have certain total cost and total loss will be 2.94 plus 3.96, 6.9. Now, let us go to the next one. We go for, now basically we have to make a levee and basically we have to see that which levee height is giving you the minimum of loss. If you go for 10 feet levee, in that case your construction cost is, so this is 20, after that 40 centimeter levee, so for 40 centimeter levee the cost is 30 lakhs. So, again for that you are having the investment cost annual as 30 lakhs multiplied by A by P 1215, that is 0.147, 4.41 lakhs. And the damage cost will be, when it is 60 centimeter, the probability is 0.16 multiplied by the loss because of the 20 centimeter height, that is 6 lakhs. So, it is multiplied by 6 plus again probability of 80 centimeter height, that is 0.06, and it will be multiplied with the loss corresponding to 40 centimeter height of the flood water level, that is 9 lakhs, and then if it is 100 centimeter height, its probability is 0.04, and then the corresponding loss will be for the 60 centimeter height, that is 12 lakh. So, it will be 0.96 plus 0.54 plus 0.48, and it will be 1.98 lakhs. So, total annual loss it will be the investment cost annual, that is 4.41 lakhs plus the damage cost, that is annual damage cost loss. So, it will be 1.98, 4.41 plus 1.98, and this will be equal to 6.39 lakhs. Now, further, if we are making the levy of 60 centimeter height, let us see what is the total annual cost which you have to bear. So, for 60 centimeter levy height construction, you have investment cost this is equal to, again for 60 centimeter height the cost is 50 lakhs, and if you want to find the annual value, it will be multiplied with the factor again A by P 1215. Now, this factor value is anyway calculated to be 0.147. So, it is coming out to be 7.35 lakhs. You further go to the loss. So, damage cost, again in this case, when the flood water level is 80 centimeter, its probability is 0.06. And in that case, the loss will be corresponding to 20 centimeter height, that is 6 lakhs. Then if the height of the water is 100 centimeter, its probability is 0.04, and in that case the loss will be corresponding to 40 centimeter, that is 9 lakhs. So, it will be 0.36 plus 0.36 and it will be 0.72 lakhs. So, total annual cost comes out to be 7.35 plus 0.72, that is 8.07 lakhs. We have to further find the loss or total annual cost for the 80 centimeter levy height and 100 centimeter levy height. We can further rub for 0 centimeter height, it is 6.86 lakhs. So, that we have to write maybe in a box. For 0 centimeter height 6.86 lakh, and for 20 centimeter height it is 6.9 lakhs. For 40 anyway we have calculated as 6.39, for 60 it is coming as 8.07. Let us calculate for the 80 centimeter levy height. For 80 centimeter levy height, the investment cost will be, this is 65 lakhs the initial cost. So, 65 multiplied by A by P 1215, that is 0.147, and that is 9.55 lakhs. Then the damage cost annually, it will be only in that case when there is 100 centimeter of flood water level, and its probability is 0.04. So, 0.04 multiplied by the damage will be corresponding to only 20 centimeter of height, and this is 6 lakhs. So, it is 0.24 lakhs. So, total cost will be 9.55 plus 0.24, that is 9.79 lakhs. Finally, if we calculate the cost for levee height of 100 centimeter, so 100 centimeter levee height. In case of 100 centimeter levee height, the investment cost annually is 80 times A by P 1215, that is 0.147. So, it will come out to be 11.76 lakhs, and the loss or damage due to the flood is 0, because this is the maximum height of the water which is reported. So, in that case total annual cost is 11.76 lakhs. What we see is that on 20 centimeter height you have 6.9 lakhs was the annual cost. On 40 centimeter height it was 6.39 lakhs. On 60 centimeter height it was 8.07 lakhs. On 80 centimeter it was 9.79 lakhs, and finally if you are making 100 centimeter, it is coming out to be 11.76 lakhs. So, what you see is the maximum loss is when you are going to make the 100 centimeter levee height, and the minimum loss annually or minimum cost what you have to incur annually is 6.39 lakhs. So, it is suggested to go for making a 40 centimeter levee which should go for 15 years, and in that case the annual cost is minimum. So, suggested height of levee is 40 centimeter. So, this is how you solve such problems where you have been given the probability values and you have to decide what should be the height of the dam in an optimum manner. Thank you.